This is the first Bluetooth-equipped wheat field.
A large percentage of the water in Western communities is used for agriculture. It's what makes the desert bloom.
It's huge, upwards of half of all freshwater used in the United States.
We identified a gap. Current technology allows people to put nutrients, water, pretty much with centimeter precision on a farm. What people didn't know was where and when to do those applications. We call this the BYU Smart Bluetooth stake. This has a lot of clever engineering in it. It employs these aluminum spikes to be able to measure the properties of the soil.
They've got a solar panel and everything they need on board that even when there's a dense crop growing above them, they're able to solar power indefinitely.
It's got a nice little brain inside here. It processes the data, and then we send this all wirelessly through Bluetooth.
They're super robust. You could drive a tractor over them and they don't break, which we found out for ourselves.
We have found that we can transmit these Bluetooth signals through hundreds of meters. And that was one of the critical technologies that we developed was, how do you do that?
To compare, the best systems that you could buy right now would cost you $250 to upwards of $1,000 per individual sensor. These, we think we can get the cost down to maybe $15 or $20 each at most.
The sensors, they send all this information to these receivers on the boom. The boom can actually upload all of this information to the cloud. That allows us then to reconstruct these moisture maps of the field.
Neil, good to see you again.
Farmers may have maybe one sensor in a field. That's almost inconceivable when you think how big a field is. We're talking 50 hectares or 100 hectares.
To date, no one has ever deployed a system of more than about 20 sensors to an entire farmed field. So we put 86 sensors out in that field and left them out there throughout several weeks with times when the irrigation boom was going around and deploying water. The goal was basically just to validate the entire system.
When we first saw the maps and we could see the soil moisture moving across the field with the boom, that was a magical moment.
This is a representation of a farmer's field, and each of these little circles is one of our sensors that we've put out there. And this red line is actually the irrigation boom moving around as it irrigates the field. And you can see even on this field, there are some areas where it looks like they're not getting enough water and other areas where it's getting too much water. And so what you could actually do is customize the speed that the boom rotates at, or some booms are even equipped with different speed nozzles along the length of the boom so that you can water every individual part of the field exactly as much as it needs.
It's been shown you can have 20 to almost 40% improvement in water use efficiency if you use precision irrigation.
I anticipate having dense networks of sensors in fields will be the future of farming. The information is just too valuable.
Our hope is to see this break out and see widespread adoption. We'd love to see farmers all over the world, and especially where it's very dry, being able to irrigate more efficiently.
All over the world, there are lots of places that are going to have water supply issues. It's all about sustainable use of finite resources.
The end goal of this project is to have the sensor information processed automatically, and the boom automatically adjusts how much water it's putting in the field. So the farmer will have an optimal irrigation strategy without having to do anything. That's a solution. That will change the world.